Every day, thousands of watermelons begin a remarkable journey inside modern processing facilities like this one. Before processing begins, every shipment is registered, weighed, and traced through the factory's digital production system. At the receiving dock, digital weighing systems record the incoming load before the fruit enters production. From the truck, the fruit is transferred onto food-grade conveyors, designed to move large quantities without unnecessary damage. Each watermelon arrives with natural differences in size, shape, color, and surface condition. Machine vision systems now examine every fruit at production speed, searching for visible defects before processing begins. The system compares visual characteristics against predefined quality parameters and flags fruit that requires further inspection. When a fruit falls outside the required specification, automated sorting equipment can redirect it without stopping the production line. Once the fruit passes inspection, the next step is cleaning the outer surface before cutting and extraction. High-volume washing removes field residue and prepares the fruit for hygienic processing. After washing, controlled airflow removes excess surface water before the fruit moves deeper into the processing line. With the raw fruit cleaned and inspected, the production line is ready for the transformation from whole watermelon to fresh red juice. After inspection and washing, each watermelon is carefully positioned for the first major transformation of the process. Precision positioning allows the cutting equipment to work continuously while minimizing unnecessary impact on the fruit. Inside the guarded cutting station, synchronized equipment divides the fruit at controlled speed and consistent dimensions. The cut exposes the dense red flesh that contains the juice and natural sugars the factory is designed to recover. Once opened, the fruit moves directly toward the extraction system, where the edible flesh will be separated from the unwanted material. The heart of the process begins here, where mechanical extraction separates the liquid-rich flesh from the solid structure of the fruit. Controlled mechanical action breaks the watermelon flesh into a pumpable pulp, while the liquid fraction begins its journey through the line. At this stage, the juice still contains seeds, fibers, and suspended fruit particles that must be separated. Mechanical separation removes larger seeds and fibrous material while allowing the liquid portion to continue through the process. After the first separation stage, the juice becomes smoother and moves into finer filtration and quality control stages. From extraction, the juice enters enclosed stainless steel processing equipment, where its quality can be controlled under hygienic conditions. Inside the processing tank, controlled mixing keeps the juice uniform, while sensors continuously monitor key production conditions. The controlled juice stream now moves toward finer filtration, where the texture and consistency are refined before thermal processing. Fine filtration removes remaining microscopic fruit particles and helps create the smooth texture expected from finished watermelon juice. At the finer filtration stage, the liquid becomes cleaner and more uniform while retaining the characteristic color of fresh watermelon. Inline sensors continuously monitor the juice as it moves through the closed processing system. Behind the equipment, automated control systems coordinate pumps, valves, and sensors to keep the process stable. The refined juice is temporarily held in a controlled tank before thermal treatment. Before heat treatment begins, sensors continuously measure the product conditions entering the pasteurization system. The juice now enters a controlled pasteurization system designed to apply carefully managed heat before packaging. Controlled thermal treatment helps reduce unwanted microorganisms, while automated sensors maintain the required processing conditions. After thermal treatment, the juice is rapidly brought toward its required processing temperature before final filling. The finished juice is held under controlled conditions while the factory prepares the next stage, high-speed bottling. A final automated inspection verifies that the juice meets the required visual and process specifications before it reaches the filling line. With processing complete, the liquid now enters one of the fastest stages of the entire factory: automated bottling. At the filling line, synchronized nozzles dispense precise volumes of watermelon juice into hundreds of bottles every minute. Each bottle leaves the filling station with a controlled amount of juice before immediately moving towards sealing. Immediately after filling, each bottle is sealed automatically to protect the juice from external contamination. Before labeling, machine vision checks every bottle for visible packaging defects and consistency. Approved bottles are then labeled automatically, giving each product its identity and production information. Production codes provide traceability, allowing each bottle to be connected to its manufacturing batch. Once labeled and coded, the bottles are grouped and prepared for efficient transport and distribution. Robotic packaging systems coordinate bottles and cartons with precise, repeatable movements. The packed cases are then stacked into stable pallet configurations, ready for storage and shipment. From the production line, finished pallets enter the smart warehouse, where automated logistics systems organize inventory for distribution. Digital warehouse systems track inventory locations and coordinate movement, so finished products can be retrieved efficiently when orders arrive. When an order is released, automated vehicles move the required pallets from storage toward dispatch. The final stage of the factory journey begins as finished products leave storage and enter the distribution network. After passing through processing, inspection, and packaging, the finished watermelon juice is finally ready to leave the factory. Electric material handling equipment transfers the finished product from the warehouse staging area to the transport vehicle. Inside the transport vehicle, pallets are positioned to maximize stability and efficient use of cargo space. Digital scanning links each shipment to its production batch and destination, maintaining traceability throughout the supply chain. From a single watermelon entering the receiving dock to thousands of bottles leaving for consumers, every stage is connected by a carefully controlled industrial system. The finished product now enters a wider logistics network, connecting the processing plant with retailers, restaurants, and consumers. At regional distribution centers, finished products are organized according to demand before their final journey to individual markets.
Digital inventory systems help coordinate product locations, orders, and replenishment throughout the distribution network.
When an order is received, automated systems identify the correct pallet and coordinate its movement to the dispatch area. Autonomous vehicles can move finished products continuously while coordinating their routes around other warehouse operations. From here, carefully organized shipments are prepared for different destinations according to real-time demand. The final distribution stage brings the bottled juice from the industrial supply chain to the places where consumers can purchase it.
After traveling through farms, factories, warehouses, and logistics networks, the finished product finally reaches the consumer.
What began as a whole watermelon has become a carefully processed and packaged drink, transformed through dozens of controlled industrial steps. But modern food production is not only about speed and volume. It is also about reducing waste. The parts of the watermelon that do not become juice are collected separately, creating opportunities for responsible byproduct management. Organic processing residues can be collected for appropriate recovery or further processing, instead of simply becoming uncontrolled waste. Water used throughout food processing must be carefully managed, treated, and monitored according to the facility's operating requirements. Digital monitoring also helps modern factories understand where energy is being consumed and where efficiency improvements can be made. From raw fruit to finished bottles, modern food factories connect every stage through automation, sensors, data, and carefully engineered processes. Behind every bottle of watermelon juice is a complex journey of agriculture, engineering, automation, and human expertise working together. From a whole watermelon entering the factory to a finished bottle ready for the world, every step is a story of modern food production. Long before the fruit reaches the factory, the journey begins in the fields, where watermelons are carefully cultivated for harvest. At harvest, farmers look for fruit that has developed the size, color, and maturity required for processing.
Modern farms increasingly use cameras and sensors to monitor crop conditions and identify fruit approaching harvest maturity.
Aerial monitoring provides farmers with detailed information about large areas of the crop before harvesting begins. Once the crop reaches the required maturity, harvesting equipment carefully collects the fruit while minimizing unnecessary damage. Soft handling systems help move the harvested fruit from the field while reducing impacts that could damage the rind. After harvest, the watermelons are loaded into transport vehicles for their journey to the processing facility. The harvested fruit now leaves the farm and enters the supply chain that connects agriculture with industrial food production. At the processing plant, the raw fruit is about to enter a highly controlled production environment. The factory begins by digitally registering the shipment so the raw material can be traced throughout production. Before unloading, the incoming fruit is weighed, and its shipment data is recorded in the factory system. From the delivery truck, the watermelons enter the first conveyor of the processing line, beginning their transformation from whole fruit to finished juice. Each watermelon carries the characteristics of the growing environment, so the factory must evaluate the fruit before processing. Machine vision can examine the fruit rapidly, identifying visible defects and differences in size and appearance. Based on predefined quality requirements, the sorting system separates fruit for different processing paths without stopping the main production line. After inspection, the approved fruit moves into a dedicated washing system before cutting and juice extraction begin. With the fruit cleaned and inspected, the production line prepares each watermelon for controlled cutting and extraction. Before cutting, each watermelon is positioned precisely so the processing equipment can operate continuously and consistently. Inside the guarded cutting station, synchronized blades divide the fruit at controlled speed, while safety systems monitor the operation.
Once opened, the watermelon reveals the red flesh that contains the liquid and natural sugars destined for extraction.
The cut fruit now moves directly toward mechanical extraction, where the liquid-rich flesh will be separated from seeds and structural material. At the heart of the process, controlled mechanical extraction transforms the cut fruit into a pumpable watermelon pulp.
Mechanical action breaks down the flesh while allowing the liquid portion to separate from larger solid particles.
The freshly produced pulp still contains seeds and fibrous material, so the next stage separates these unwanted solids from the juice. Specialized separation equipment removes larger seeds and fibrous material while allowing the liquid-rich fraction to continue through the process.
After separation, the juice becomes smoother and moves into the next stage for finer filtration and process control.
From mechanical separation, the juice enters a closed sanitary pipeline where automated systems control its movement through finer filtration. Fine filtration further refines the juice, creating a more consistent liquid before thermal treatment and final packaging. The finer filtration stage removes remaining suspended material and helps produce a smoother, more uniform juice. Throughout the process, inline sensors provide continuous information that helps maintain consistent production conditions. The refined juice is temporarily held in a controlled tank before entering the thermal processing stage. From the holding tank, the juice moves into the thermal treatment system, where temperature becomes the critical process variable. The next stage uses controlled thermal treatment to improve product safety, while automated sensors continuously monitor the process. Temperature and flow are monitored continuously, so the treatment remains within the controlled operating range. After heat treatment, the juice is carefully cooled to prepare it for the final packaging process. Once thermal processing and cooling are complete, the finished juice is held under controlled conditions before bottling. The processed juice now leaves the preparation area and moves toward the final transformation from liquid product into packaged bottles. Here, the carefully processed red juice meets the final stage of its industrial journey: high-speed automated bottling. After hours of controlled processing, the finished watermelon juice finally reaches the high-speed bottling line. Before filling begins, Every bottle is positioned precisely beneath the synchronized dispensing heads. Precisely controlled filling nozzles dispense the watermelon juice into each bottle at high production speed. The filling system controls the volume of every bottle while maintaining a continuous, hygienic production flow. When the target fill level is reached, the nozzles stop with precise timing, and the bottles continue toward sealing. Immediately after filling, the bottles move directly toward automated sealing to protect the product from the surrounding environment. At the next station, caps are automatically oriented and delivered to the capping heads at production speed. Each cap must be aligned accurately before the sealing mechanism applies the required closure. Automated capping systems seal the bottles rapidly while maintaining consistent closure performance across the production line. Machine vision checks the sealed bottles for visible closure problems before they continue through packaging. If a bottle fails the inspection criteria, automated equipment removes it from the main production flow for further evaluation. Approved bottles continue to automated labeling, where product identity and traceability information are added. High-speed labeling equipment keeps every package visually consistent while applying the required product information. A unique production code links each bottle to its manufacturing batch and supports traceability through the supply chain. Before packaging into cartons, every finished bottle passes through another layer of automated quality inspection. Computer vision systems can identify visible packaging inconsistencies at production speed without interrupting the main conveyor. Once approved, the bottles are grouped into precise formations for secondary packaging and transport. Robotic case packing systems place the finished bottles into transport cartons with repeatable precision. The filled cartons are sealed automatically, protecting the bottles during storage and transportation. At the end of packaging, industrial robots build stable pallet loads ready for automated warehouse handling. Stretch wrapping secures the finished pallet and prepares it for movement into storage. With packaging complete, autonomous logistics systems take over the movement of finished products. Once packaged, the watermelon juice enters a smart warehouse where every pallet can be tracked from storage to final delivery. Each pallet is digitally identified, allowing the warehouse system to know exactly what has arrived and where it is stored. Every storage movement is confirmed digitally, creating a continuous traceable record from production to distribution.